Hello Shirley team, and welcome to August Supervisor Safety Meeting. Today we're at Washington Gas's 811 event here in Fairfax, celebrating Call Before You Dig with some of our industry partners. And this month's Supervisor Safety Meeting topic is going to be on, of course, trenching, something that we do quite a lot of. OSHA came out with a news bleep back in the 1st of July that, believe it or not, the first 6 months of 2022, there have been 22 fatalities related to trench incidents across the country, surpassing the 15 fatalities that occurred in 2021. So we felt it was important for this month for us to cover trenching. And as I said, today we're out working with our industry partners discussing trenching and call 811, miss utility before you dig. Just a reminder, also take care of your dig permits each month. All this is very important to us. With that said, 3 individuals from the Field Safety Committee have a presentation put together for you guys for this month. And as a reminder, the September Supervisor Safety Meeting will be in person at the Fiesta Event Center in Manassas, the same venue we've utilized for the last 2 in-person meetings. Thank you, and if you need anything, feel free to reach out to the Safety Department or your assigned safety manager or myself. Have a great day.
Hey, good morning. My name is Bud Mullins. I'm one of the newer superintendents here at Shirley, and I have been asked to speak on 3 different subjects. One being access and egress, which simply just means to enter and exit. This could be in a structure building, but primarily I'm going to be talking about our trench excavation, since that's mainly what we do here at Clover. In 1926.651-2, that's page 356 of your handbooks, this is where it discusses and covers access and egress. The means of access and egress from a trench excavation, the stairway, a ladder, a ramp, or safe means egress shall be located in trench excavations that are 4 feet or more in depth, to require no more than 25 feet of lateral travel for employees. So what I've done is I've excavated a mock trench to give you kind of an idea of those 3 different types of access and egress. If you can actually come over here and see, I've dug a trench. This trench is actually 6 foot deep. That's just because I'm going to be explaining something later on. But actually at 4 feet, you are to provide a ramp, like I've excavated on one side of the trench, a set of steps, earthen steps, like I've excavated on the other side, or provide a ladder that extends at least a minimum of 3 foot out of the excavation and is tied off and secured. If you're using trench boxes, things of that nature, do not tie your ladder off to that trench box because of the movement and the danger it could cause. Now, some people have always wondered, like, why 25 feet of lateral? A lot of times in OSHA, when they're talking, they always say a minimum requirement. However, when it comes to the 25 foot mark of for a ladder for access and egress, they say a maximum. The reason why is at 25 feet, pretty much when they were setting this standard, that's the distance that a man the average man can actually run in lateral movement without getting out of breath. Again, also at the access and egress points, make sure that you control housekeeping. You keep everything clean so there's no tripping and falling. It's easy to get in and out of the trench. And if you're using a guardrail system, for example, make sure your access and egress, your ladders or whatever, are located at a gate. All right. Another subject, I'm saving one for last since our longest, but another subject I've asked to speak on is exposed utilities and support. Now, they really don't clarify this, and I couldn't find in the 1926 OSHA standards. However, being in the utility field and speaking with some other utility contractors, if you have more than 10 foot of a utility exposed, especially in a duct bank system, you have to support the weight. If not, it could collapse. Not only could this be deadly, it could put a large area out of service and cost the company a lot of money. So to support the utility, first, I always tell you to contact an engineer because of the weights and other things that you will, the variables that you'll come across. But the common practice is to use a steel I-beam that extends 3 foot over on each side of the exposed utility to the original ground and strapped with the 3/8 chain and binder that supports, I think it's like 3,000 PSI. And they should be separated the maximum is about 3 foot apart or closer. And actually here at Clover, we'd actually had come across this situation where we had to take and run a sewer line under an existing duct bank, and I will provide the photos and everything for you and the engineer drawing for you to give you a better idea. The last thing I was asked to speak on is fall protection. This has been subpart M. This is 1926.500. It's page 329 of your handbooks. Now this is a large section, so primarily I'm just going to cover what pertains to us here at Clover and our trenching excavations. Okay, again, this is a large section. I will talk about anchorage, body harness, buckles, connectors, deceleration devices, deceleration distance, free fall distance, guardrail system, lanyards, and personal fall arrest systems. Again, I told you this is a big section. So when working 6 feet above or below, fall protection is required by using guardrail, fences, barricades, etc. First, I want to talk about guardrails. The top edge shall be 42 inches, give or take 3 inches either way, so it could be at 45 or 39 inches. You should have at least one mid-rail 21 inches in height from your working surface. Toe board shall be 3.5 inches high from the working surface and withstand 50 pounds of pressure in the downward or outward motion. Top rail should be capable of withstanding, without failure, a force of 200 pounds within 2 inches of the top rail of any outward or downward direction at any point along the top edge. Personal fall arrest system. That's your, just a reminder, body belts are not allowed anymore. So I'll start talking about the different parts of a body harness. All right. You have connectors that should be drop forged and corrosion resistant. D-rings and snap hooks shall have a tensile strength of 5,000 pounds and be tested at a minimum tensile load of 3,600 pounds without cracking or breaking. Snap hooks should only be the locking type. They should not be engaged directly to welding ropes, to each other, to a lifeline, horizontal, or to a D-ring that has another snap hook. Lanyards shall have a minimum breaking strength of 5,000 pounds. Self-retracting lifelines I'll talk about also, I mentioned, and lanyards, which automatically limit free fall distance to 2 feet or less, shall sustain a minimum tensile load of 3,000 pounds applied to the device in any extended position. Anchorage is another big subject. It should be independent and can support at least 5,000 pounds per employee attached to the designed, installed, and used to the device. And there are some criteria to this. See, your maximum arresting force on an employee to an employee is 1,800 pounds. When using a body harness. Can't free fall more than 6 feet nor contact any lower level. Bring an employee to a complete stop and limit maximum deacceleration distance to 3.5 feet. It also can withstand twice the potential impact energy of an employee free falling 6 feet. Also remember, personal fall arrest systems shall not be attached to any of the guardrails or hoist. One of the things that I want to talk about also is equipment inspections and training. It's very vital that you take and inspect your body harness at least every day. D-rings, again, I may have forgot to mention this, but in a body harness, the D-ring that we use now It has to be in the middle of the shoulders of the back. And the D-ring, check it to make sure there's no tears or frays around the D-ring, and the D-ring is not misshaped. The body belt, check it real good again for any frays or tears or anything. If not, if it does have it, take it out of commission immediately. Also, there is a tag, there's a special flap. You pull that tag open, and your body harness should be inspected once a year, and it should have a date and who inspected and everything written on there. All right, so when you're inspecting your body harness, there is a tag on your body harness that tells you when the last date was that it was inspected. It should be monthly. Also, the inspection should be done after every use. That's in the morning time before you start, after lunch, at the end of the day, or whenever you have taken this off and you're going to reapply the body harness. Training, I believe, is another very important thing here. A lot of times I would ask the employees and superintendents to set up a mock recovery. This could be done in manholes, which we also work with out here a lot, in excavation and trenches, just to give the individuals a feel of what it actually takes to actually recover someone, God forbid, in a situation where they've been injured or hurt within a trench or within a manhole, especially when using a tripod. A lot of times I see they set the tripods off center of a hole instead of directly over a hole, and this is crucial if you were to ever have to retrieve someone or pull someone back up out of a structure. Other than that, I'd just like to thank you for giving me this opportunity. Thank you.
Hi everyone, my name is Steve Edson. I'm a senior project engineer with Shirley Contracting, and I'm currently serving at both our Project Speedway and Arthur Ashe ramp widening projects down in Richmond, Virginia. I've been with Shirley for almost a year now, and I'm honored to be a part of our safety committee, which aims to significantly reduce the number of recordable incidents we have, and of course, ensure that each one of us gets home safely to our families every night. For this video safety brief, I'm going to be covering 3 key aspects of trenching and excavation safety: soil classification, sloping and benching, and everyone's favorite, dig permits. Unfortunately, more than 800 construction workers die each and every year on the job. Trenching and excavation is one of the most dangerous evolutions in construction and takes the lives of nearly 40 construction workers every year. As our safety director, Sean Nick, probably stated at the beginning of this video, in the first 6 months of 2022 alone, the U.S. had unfortunately already lost 22 lives in trenching and excavation cave-ins. Crew members can suffer death or serious bodily harm within just minutes of a cave-in, with 75% of those deaths happening in trenches and excavations of 15 feet or less, and nearly 40% of those deaths happening in trenches and excavations at a depth of just 10 feet or less. While those numbers are staggering to say the least, the important thing to take away from those numbers is that these injuries and deaths can be prevented. By going over the safety standards that Shirley expects of its crews and on its job sites, we can do our part in reducing these unfortunate incidents. So our first topic, soil classifications. One of the most critical actions you can take to reduce the chance of a trenching or excavating related injury or death is classifying the type of soil that you are working with, understanding its unique qualities and characteristics. Knowing the type of soil makes it possible to determine the right protective system to keep you and your crew safe when they are working in a trench or other type of excavation activity. So why is soil classification so important? Well, 1 cubic yard of soil can weigh as much as a small sedan, 3,000 pounds, and it comes in many different varieties. Some types of soil are stable, or as we say, cohesive, and some are not, which we would call granular. When digging, it is important to know which type of soil you are working in so you know how to properly slope, bench, and shore the trench or other type of excavation you are working in. Cohesive soil contains fine particles and enough clay so that the soil will stick to itself. The more cohesive the soil, the more clay it has, and the less likely you are to have a cave-in. Conversely, granular soils are made of coarse particles like gravel and sand. This type of soil will not stick to itself. The less cohesive the soil is, the greater chance that you are to have a cave-in, which means the greater measures that you need to prevent a cave-in. OSHA uses a measurement called unconfined compressive strength to classify each type of soil. This is the amount of pressure that will cause the soil to collapse. That value is usually reported in units of tons per square foot. OSHA also requires that employers have a competent person on site to determine the soil type. And of course, we all should know a competent person is defined as someone who A, has the experience and capability to identify hazardous conditions for our crews, and B, has the authority to place prompt corrective measures and actions. So soil types. There are 3 types of soil classifications: type A, type B, and type C. Type A soil is the most stable soil in which to excavate. Type C soil is the least. It is important to remember that a trench can be cut through more than one type of soil. It is Shirley Contracting Company policy that we assume all soil that we work in is type C, which means we should maintain the highest standards of safety when operating in a trenching and excavating environment. So type A soil. Type A soil is cohesive and has a high compressive strength, 1.5 tons per square foot or greater. Examples of type A soil include clay, silty clay, sandy clay, and clay loam. Soil cannot be classified as type A if it is fissured, if it has been previously disturbed, if it has water seeping through it, or if it is subject to vibration from sources such as heavy traffic or pile drivers. Type B soil is cohesive soil that has been cracked or disturbed, with pieces that do not stick together as well as type A soil. Type B soil has a medium unconfined compressive strength between 0.5 and 1.5 tons per square foot. Examples of type B soil include angular gravel, silt loam, and soils that are fissured or near sources of vibration. Sometimes, a soil that has type A characteristics is classified as type B simply due to its close proximity to heavy road traffic or other sources of vibration. Type C is the least stable type of soil. Type C includes granular soils in which particles do not stick together, and cohesive soils with a low unconfined compressive strength, 0.5 tons per square foot or less. Examples of type C soil include gravel and sand. Because it is not stable, any soil that has seeping water through it is automatically classified as type C soil, regardless of its other characteristics. Again, it is Shirley Contracting Company policy that we assume that all soils that we work in are type C, therefore requiring the highest level of safety standards for all trenching and excavation operations. So sloping and benching. Sloping means a method of protecting employees by cave-ins by excavating to form sides of an excavation that are inclined away from the excavation, which helps to prevent cave-ins. For type A soil, the maximum allowable slope is 20-foot depth with a 3/4 to 1 slope, or 53 degrees. For type B soil, the maximum allowable slope is 20-foot depth with a 1-to-1 slope, or 45-degree angle. For the kind of work that we do at Shirley, type C soil, the maximum allowable slope is again 20-foot depth with a 1.5 to 1 slope, or a 34-degree angle. Dirt spoils must be placed at least 2 feet back from the high edge of the slope, thus creating a proper benching of your excavation. And finally, dig permits. Dig permits are required for all land disturbing activities. From trenching and excavating to something as simple as putting a shovel in the dirt, Shirley Contracting is required to submit a dig permit. Even something as simple as putting in place temporary construction signs at the very start of your project will require a dig permit. The first step in filling out a dig permit is calling in a missed utility ticket. It will take 3 days for your request to clear, So please make sure you are building in enough time in your work plans to account for this. Make sure to always look for evidence of an unmarked utility. This can come in the form of a handhole or a pedestal. If you do find clear evidence of an unmarked utility and you have an active missed utility ticket, you can then call in a 3-hour notice to have that utility marked. Color codes for marking utility lines are as follows. Red equals electrical power lines, cables, conduit, and lighting cables. Yellow is gas, oil, steam, petroleum, or other gaseous materials. Orange is communication, alarm or signal lines, cables or conduit. Blue is potable water. Green are sewers and drain lines. And purple is reclaimed water, irrigation, and slurry lines. Once your missed utility ticket has been cleared and all utilities are clearly marked, you will then go about completing a dig permit. Very straightforward, simple permit. It will start with your foreman. You will then go to your utility superintendent. And finally, it'll be signed off by your project's safety manager. Understanding the type of soil you are working in, having in place the proper sloping and benching standards, and having up-to-date, correctly filled out and filed dig permits are all important aspects of trenching and excavation. I hope you have taken something measurable away from this, and I thank you for your time.
Hey guys, Jonah Ringeisen over here at Route 7. I'm a field engineer. I've been on this job site for almost 2 years now, almost 3 years with Shirley. So seen a lot of interesting stuff on this job site. We got a lot going on, a lot of pipe work, a lot of ditches, a lot of trenches, a lot of slopes we're doing out here, and that's what I'm going to get into talking about today, and how we can protect ourselves not only now but in the future and plan properly. So out here on Route 7, one of the first things we did when we got out here was meet with the local fire department, Fairfax County Fire and Rescue. Brought them out here, kind of showed them what we're going to be doing, where we're going to be working, and kind of gave them an introduction to our scopes and what we do so that they would know what's going on and what they might need if we call them and we have an issue. One of the biggest things would be the trench collapse, things like that. So they informed us of where the closest technical rescue crews are. They have many of those in Fairfax County, some of the top in the country actually. So after that, some of the things we did was look into some of these deep excavations we got out here and some of the deep pipe that needs to be put in, and we start to pre-plan what we need out here, what we're going to need in the future, and that helps us have an idea how we're going to keep our guys safe. So once we get into that, we have a couple companies out here that we can contact. Canelco is one of the big ones we use for getting all our trench equipment, and they've been very helpful getting this stuff out here. Once we formulated a plan and looked at what we're going to be doing and figured out whether we're going to need, if we're going to slope it, we're going to bench it, we might need to get in there and use a trench box, manhole box, a build-a box, or slide rail. There are many things we have access to. Especially on this job, not everything's the same, so you might be using a different type of box for something you wouldn't generally use it. We got to make sure we have those. When those show up, we need to be doing an inspection on those, make sure that the box looks right, there's no damages. We need to make sure that we have the proper pins, the proper keepers. If we're stacking them, we need to make sure we have the stacker pins, all 4 of them, and make sure there's no bent spreaders, there's no holes in the box, and there's no major damage. Anything that would stick out that looks like it's not going to be right, we need to say something about it and get that fixed right away. With that, when we have this type of equipment show up, we should have a tabulated data sheet show up with it. For our stuff, we already have our own sheet with it. This basically gives the specifications of the box and the max limits of them and how we're supposed to use them. Foremen need to have these on hand as well as the job site has them on hand. Foremen keep a binder with them so that they know. If for some reason one shows up and you don't get it, talk to your superintendent. They can find out where the box came from and why we didn't get that with the box. So once we start to get into our excavation part, when we're digging, we need to keep it tight. We need to make sure that the box is going to fit in there right. If we over dig, we don't want to dig out too far. and we don't want to dig too wide. If we do, we need to backfill it. Once the box is set in there, got to make sure the box is a minimum of 18 inches sticking up from the ground and maximum of 24 inches sticking up from the bottom. And then at the top, we got to have our rail. Unless it's 42 inches high, we don't have to have railing around it. As we're digging out for our box and our trench box or slope, whatever we're using, we got to make sure that that material is being stored at least 2 feet away. If it's stored within 2 feet of our excavation, it becomes part of the excavation. So, and then if we're 20 feet or deeper, we got to look into that, because 20 feet or deeper is going to require an engineer stamp of approval, which we have the ability to do. We just need to do it. Generally, when we're sloping a ditch, there's different types of slopes for different types of soil classifications, but generally, you can never be wrong if you do 1.5 to 1. That's your type C, and that'll keep you safe for pretty much everyone. 1.5 to 1 will keep us safe. Once you've done this, you're going to have your ladder. You need to have your ladder every 25 feet. If you got a ditch that's 50 feet long, you can put the ladder right in the middle. You need to have access to a ladder 25 feet away from where you're working. That ladder is going to be used when we're 4 feet or deeper. You can use it for less, but 4 feet or deeper, it's required. That ladder needs to be protruding 3 feet up in the air, so that you can, out of the ditch, I should say, so that you have proper ability to hang on to it and have 3 points contact. That ladder also needs to be an extension ladder, and not just part of an extension ladder. We have that sometimes. We break part of the ladder and we use the other half. You need to have a full extension ladder. It needs to be working. If it's not, you can get a new one. That ladder, last thing with the ladder needs to be in the box, not outside the box. We want everyone working in the ditch to stay in the box. So once we make sure that our ditch is safe and we're ready to begin laying pipe and all that, we got to make sure that our surface protection is in place. Up on top, obviously, we got the railing we talked about earlier, and then a couple things we can put around to help warn people that are walking around, not just random people, but our guys, is open trench signs. You can get those from the office or your safety person. Talk to your safety person. They can print those out. Another thing is to have safety fence around any hole, any slope we have. Not only do we want safety fence around, we want that safety fence staying back 6 feet. 6 feet or more, honestly. It doesn't, more is okay. And then if we're working near traffic within the clear zone, we need to have barrier. We can't be leaving a ditch overnight. Barrier, plates, either or. We can't leave a hole in the road with safety fence. Safety fence isn't going to hold a car from falling down in a 20-foot ditch. So we don't want that happening. So every day when we come into work, we need to be inspecting our ditch and our work area. Not just the surface. We need to be looking down in the ditch before we even go down there. Before anyone steps foot on that ladder and goes down into the ditch, we need to inspect it. A lot of times I've come back in the morning, the box has slid down. Even if there's not a rainstorm, they'll slide down. Just movement of the earth, it happens. So when you come in, things we want to look for are the boxes moving around. If you're using hydraulic jacks, maybe they've lost a little bit of pressure overnight and they've slid down. You need to make sure they're where they were, get them back where they were. If they don't seem to be working right, let's make some phone calls, get some new ones out there. So other things to look for is change in wall slope, settlement of the dirt, cracks, and water seeping. Those are just a few of the many things. Obviously, look at it before you leave, make sure it's right, come back the next morning, make sure it looks the same way. For some people, if you can't remember, take a picture of it. Snap a picture of it real quick, look at it next morning, make sure everything looks right. Easy enough for you. So again, things can change overnight. We don't know what happens when we're at home sleeping, and we don't want to come in and forget to check something and we get hurt. Check it every day. Probably the most important thing you can do. As co-workers, we're a team. The Shirley team, we got to look out for each other. Every day when we come to work, keep an eye on each other. If something looks wrong, say something. Keep an eye on each other's backs. Sometimes you got to turn and grab something. Hopefully your buddy's watching your back. We should all be doing it for each other. Things change quickly. It only takes 2 seconds for a trench to cave in and someone's injured. Another thing, don't only be safe when superintendents are around or safety managers are around. These things are put into place to not just satisfy a checklist that the safety managers do, but to keep us safe. They're put in place because at some point in time, someone was injured. These are to keep us safe. We want to go home every day. We spend a lot of time at work, but we want to go home to our family every night. And I can just emphasize, guys, that we got to be careful. There's numerous accidents every single year that happen in trenches, ditches, slope cave-ins, all that kind of stuff. We just got to be careful, keep an eye on each other. 1 cubic yard of dirt can weigh about as much as a compact car, 3,000 pounds, and it can kill you. It'll suffocate you, it'll crush you. 3 takeaways from today, guys. So first one is plan. Make the plan. When we make that plan, we got to execute it. When we get the materials we have, inspect it, make sure everything looks good, let everybody know, make sure we know how that operation is going to go. 2, inspect. Every day when we come in, keep an eye on it, make sure everything looks good. Doesn't even have to be every day. Check every little bit, every hour. Keep an eye on it. Constantly keep your eye on these slopes and ditches, everything going on around you. Changing out here all the time, guys. The traffic changes every day. We got different subs. We got a lot of work going into place right now all over the area. So we're starting to hire more subs, get them out there. If you see them doing something that might not be safe, say something about it. We got to all keep an eye on each other's backs. They might not see it. They might not notice it. They may have other things going on. They just don't see it. We got to say things to each other and talk. Communication is a huge part of being successful and keeping us all safe. In closing, we're all out here trying to improve Route 7, and as well as many other jobs. We're trying to improve it, we're trying to make it better, and we're going to come down here for years and pass down these roads, and we're going to remember, and some of us are going to tell our kids, I built that road. We don't want to have bad memories. We want to be able to come down and say, we did that and we did that safely. Thanks, guys.